Hello, welcome again. We are solving some questions of fluid mechanics and machinery. The topic is kinematics and dynamics of flow. The expression curly pi by curly t plus integration dp by p plus 1 by 2 delta pi whole square plus gz is equal to constant represents. Option A steady flow energy equation. Option B unsteady irrotational Bernoulli's equation, and option C steady irrotational Bernoulli's equation. Option D unsteady rotational Bernoulli's equation. This is rho. Okay. So this is an unsteady flow because this is pi is varying with time. Okay. As pi exists, so it is a possible case of irrotational flow. So it is unsteady irrotational Bernoulli's equation. Okay. So answer is option B. So as pi exists, it is a possible case of irrotational flow. Pi varies with time, so it is the case of unsteady flow. As pi expression contains pressure variation, velocity variation, and atom head, so it is representing energy equation or Bernoulli's equation, but it is unsteady. Okay. Next, at 2 points 1 and 2 in a pipeline with velocities r v and 2v respectively, both the points are at the same elevation. The fluid density is rho. The flow can be assumed to be incompressible, inviscid, steady and irrotational. The pressure difference in pressure P1 and P2 at points 1 and 2 is option A 0.5 rho v square, option B 1.5 rho v square, option C 2 rho v square, option D 3 rho v square. Okay. So suppose here this is the location 1 and this is location 2. Here the velocity is v and here the velocity is 2v. Pressure at 1 is P1 and 2 is P2. So applying Bernoulli's equation between 2 and 1 and 2, so P1 by rho g plus V1 square by 2g plus G1 plus Z1 is equal to P2 by rho g V2 square by 2g plus Z2. As elevation is same, so Z1 is equal to Z2, and velocity is velocity is 2 times of that velocity, inlet velocity, because here the velocity is v, here the velocity is 2v, so it will be 4v square by 2g, and here will be v square by 2. So P1 minus P2 by rho g will be here 1.5 square v square by g, or it will be P1 minus P2 will be 1.5 rho v square. So answer is option B. Next, a venturimeter of 20 mm throat diameter is used to measure the velocity of water in a horizontal pipe of 40 mm diameter. If the pressure difference between the pipe and throat sections is found to be 30 kPa, then neglecting friction losses, flow velocity is option A 0.2 meter per second, option B 1 meter per second, option C 1.4 meter per second, and option D 2 meter per second. So here the throat is, here is throat 20 mm, and here 40 mm. Okay. So let V1 be the velocity at 1 and 2, V2 be the velocity at 2. So P1 and P2 are the corresponding value of pressure at 1 and 2. So applying Bernoulli equation, again same thing, P1 by rho g plus V1 by square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2. So as Z1 is equal to Z2, so we can write P1 minus P2 by rho g is equal to V2 square by 2g minus V1 square by 2g, and discharge is suppose Q, and velocity at section 1 and 2 can be determined by dividing their area. So Q divided by pi by 4 into 20 square, and V1 is Q by divided by pi by 4 40 square. So V2 by V1 is equal to 40 square by 20 square, or V2 by V1 is here 4. Okay, so V2 is equal to 4 V1. Okay, so P1 minus P2 is your 30 kPa. Okay, so that is given. So 30 into the 2000 divided by 100. So putting here, okay, putting here we can find out putting the value of V2, because V2 is 4 V1. Okay, and putting the value of pressure 30 kPa G. So we can find out V1 as 2 meter per second. So velocity at section 1 is 2 meter per second. So answer is option D, or the velocity in the pipeline is, okay, is option D, 2 meter per second. Next, air flows through a venturi and into atmosphere. Air density is rho, atmospheric pressure is Pa, throat diameter is dt, exit diameter is d, and exit velocity is u. The throat is connected to a cylinder containing a frictionless piston attached to a spring. The spring constant is K. The bottom surface of the piston is exposed to atmosphere. Due to flow, the piston moves by distance x, assuming incompressible flow. X is option A, rho u square by 2k pi ds square. Option B, rho u square by 8k d square minus by dt square minus 1 pi ds square. Option C, rho u square divided by 2k bracket d square minus by dt square minus 1 pi ds square. Option D, rho u square by 8k d square by dt square minus 1 pi ds square. Okay, so this is your diameter, throat diameter, this is u, this is ds, this is x, displacement due to flow. Okay, so here so this is your velocity u and this is pressure Pa, and this is ds. This is your piston, and so u is the velocity at exit, okay, and d is diameter at exit. Okay, dt is throat diameter. Okay, so from continuity equation, velocity at throat is pi by 4 d square u is equal to pi by 4 dt square dt, here and here. Okay, and vt is velocity at throat, so vt will be 4 d square by dt square. Now we can apply, now we have velocity in terms of u, so we can apply Bernoulli's equation here and here to find out pressure here. Okay, so applying Bernoulli's equation, taking it as P1 and it has taking it as 1 and it has 2. So P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2. Z1 is equal to Z2. So P1 is your throat pressure Pt by rho g, and V1 is your 4d square by dt square that we have calculated, and this is your P2 is atmospheric pressure Pa, and this is your d square. And from this we get Pt minus Pt by rho g minus P by rho g is equal to u square minus u square d square by dt4 d4 by dt4 by 2g, or we get u square by 2g bracket 1 minus d4 by dt4, okay, or Pt by Pa is rho u square minus by 2 Pt 1 minus d4 by dt square. So here again at the throat the pressure is Pt, and at this at the one end of the spring the pressure is Pt, and here the pressure is Pa. So the difference of this pressure gives the deflection. So now we have calculated Pt minus Pa. Now we can divide it by we can multiply it by area. For force, so force is this this is your Pt minus Pa, and it will multiply by area pi by 4 ds square. Ds is diameter of this piston. So then this is your F. So this is if K is the stiffness of spring, then F by X is your K. So X comes out as rho u square by 8K. Put in the value of F. Okay, and we get this. So answer is option D.